Well, once you're kicked off, you can make me host.
Awesome. Okay, we should be good to go.
Cool.
Thank you guys so much for joining us. This is Simba Cotter of Featureform. He's going to be giving a little bit of talk on Featureform and MLFlow. So Simba, I'll let you take it away.
Cool. Thanks, Marie. So, yeah, let's do it this way. Like Marie said, we're going to be uh talking about feature and model management, specifically with MLFlow and Featureform. If you are using either MLFlow and or Featureform or neither, this will be a really good talk to learn about MLOps from this aspect of training and experimentation and model management, kind of before things are in production. What does MLOps look like? A little bit about me. I'm Simba. I'm the CEO and founder here at Featureform. I started Featureform about 3 years ago. Prior to that, I was running a company where we had models such as personalization, predicting subscription, predicting churn, and we managed or handled the data of over 100 million monthly active users. So we built all sorts of in-house stuff that nowadays we call MLOps. And one of the most critical things we built nowadays we'd call a feature store. And we obviously open sourced that, and eventually that became, or it was the basis of what is now Featureform. So the agenda today, I'm going to start with a overview of what an MLOps platform is, and then I'll kind of zoom into the parts we'll talk about today, which is experiment tracking and feature stores. I'll talk about both. I'll give you some of the value props of them. I will show you some examples. Again, we'll be using MLFlow for experiment tracking, but everything I say applies to weights and biases, to Comet, to Neptune, to whatever experiment tracker you use. We'll also talk about feature stores. We'll go deep there. We'll dive into the value props, why they matter, how it looks, how it works. And in the end, we'll spend probably half the time that we have looking through code, building a model using Featureform and MLflow, and using those things to track and manage the experiments, the data, and the models. At any point in time, if you have any questions, feel free to throw them in the Q&A if you're on Zoom. And if you're on LinkedIn or Twitter, you can go ahead and just put them there, and Marie will keep an eye on them and make sure that I'm aware of them so I can answer them for you. Great. Let's do it. So let's start really simple. What's the simplest kind of uh, model that we can think about? When we first learn machine learning, we typically have this really perfect data set where we just grab some of the columns, like it could be like the iris data set. We throw them through a pretty simple model, like a linear regression. And we train, and then we use them all. We don't really use them all for anything else other than just kind of showing it as an example. Now, as we know, in a real production setting, reality is much messier. In reality, we're working across a ton of notebooks. We're building all sorts of transformations, coming up with different features, playing around with it, dealing with errors, dealing with bugs, trying different models, kind of testing different hyperparameters, running different experiments. And in the end, we kind of end up with this chaotic mess of models and features and training sets and CSVs and Python files and bash scripts and notebooks everywhere. So that's the chaos that is one of the value props of MLOps tools. The experiment trackers are much more focused on the models and the training and the hyperparameters. And then feature stores like Featureform are much more focused on the data, the transformations, the training sets, etc. There are obviously other tools just oriented just towards notebooks and other pieces of this, but there are different parts of the tool chain that kind of manage all of these things. And that's kind of one of the main goals of MLOps. Just to maybe start with what are the main goals of MLOps? There are three. I like this image. It's actually based on product delivery, but it's interesting because model delivery is very similar. There's three components. There's velocity, throughput, and risks. Velocity is how fast can a single data scientist iterate? Like how painful is it to train the model? How painful is it to build a new feature and a new training set? How long do all of those things take? Throughput is collaboration. Um, if you have many data scientists working on overlapping data or similar data sets, etc., there's value in collaboration. And the better we can do that, the better we are as a team, as a data science team. A lot of collaboration nowadays is mostly just done through Slack or just sending notebooks or sending CSVs. But the better we can get, the more reliable we can get, the faster we can move together. And finally, depending on the industry you're in, depending on what you're doing, risks are and risk reduction is a huge part of production machine learning. For example, we had a recommender system that again was powering 100 million users. Every time we updated it, there was a risk. You know, things could go wrong. What happens if the model just misbehaves and even though it did well in training, it misbehaves in production, or if a data pipeline changes or breaks? There's a ton of risk. If you're dealing with a regulated industry, like a bank or any sort of financial institution, any sort of health institution, there's another axis of this, which is compliance risk, making sure that you're balancing velocity and throughput while also making sure that things don't break and things stay compliant. So all these things these are the points of a MLOps platform. How much each dimension matters to you and where the pain points are and where you can drive most value is going to be very dependent on you individually. And so let's get a little more tactical. So this is kind of the theoretical value, the theoretical goals of a MLOps platform. Now, there's so many tools that call themselves MLOps. This is one breakdown that I've tried to make to define the MLOps landscape. So there's two things here. There's an abstraction level and stages of the ML lifecycle. I'll start with the stages of the ML lifecycle. There's really four. There's one piece which I'll generically call data, like building data sets, building training sets, building production pipelines, anything that's working with the data. Experimentation and training. This is where you are trying different experiments, you're trying different models, you are training them, etc. Once you have a trained model you want to put in production, then we get into deployment and serving. And then finally, we get to monitoring and evaluation. What I find interesting, a little bit maybe of a tangent, is how similar LLMs are to this. Like when you think of LLMs, it's data fine-tuning as opposed to training. Deployment and serving is still painful and still something that's worked on, and monitoring and evaluation is obviously one of the core pain points. But anyway, that's ML lifecycle. On the other side, we have levels of abstraction from the layer 0, which is hardware. What GPUs are we using? Where are we getting them from? Are we using AWS? Compute frameworks, if you're using Ray, if you're using Kubernetes, like however you're orchestrating that hardware. Services, which are I like to call them engines, which is like what's actually running and storing your data. What's actually training the model? Is it your local laptop? Is it SageMaker? Is it something like what's actually training the model? Deployment, like where is it being deployed? And then finally, that could be like Selden, it could be Bento, it could be something like that, and monitoring the valuation, which is where are my logs going to? The workflow layer is above that. And that's actually where MLFlow and Featureform sit in the workflow layer, which is now that, so in the MLFlow case, um, you can, in the MLFlow case, you can think of it like you have something that you're using to train. It could be like SageMaker. But the thing that's actually keeping track of your experiments, versioning them, creating something that's searchable, reusable, shareable, understandable, visualizable, all the ables, um, that's where MLflow and Featureform live. So we sit above the actual like kind of thing, the engine that's training or transforming or storing, and we make it work in a coherent way for a ML team. So yeah, you can kind of layer these this way. On the bottom, you have the different ML lifecycle components. And then on the left, we have the different layers of abstraction. As we do that, you'll find that like layer 0, which is the hardware, it just kind of applies to everything. Like the same hardware is typically used for all these things. Compute frameworks, if you're using Kubernetes or Ray or Databricks for everything or AWS for everything, like that tends to just kind of sit across the whole stack. Then we get to the services. So you'll have one service for your data, which is like the service that stores the data. It could be like Redis, it could be Spark, whatever is actually doing those things. Training service, like where is it actually being trained? Again, it could just be like a collab, it could be your laptop, it could be some other service. Serving, where is it running on Selden? Like what's the service engine that's running the model? TF serving, Kserve, etc. And then monitoring, which is where are my logs being sent to, where are they being stored? Above that is the orchestration and the management. So for the data, what's keeping track of my training sets? What's actually orchestrating and running them on Spark and storing them into Redis and doing all that stuff for me? For experiments, what is being used to keep track of my experiments that were run, keep track of all the models that get created? It's not actually running the training, but it's more like keeping track of and being the workflow for it. Same as orchestration evaluation. For this specific talk, we're going to focus on those pieces on the left. Zooming in a bit, for feature orchestration and management, we'll use Featureform. For experiment orchestration and management, we'll use MLflow. For our feature engine, our feature service, we'll use Redis and Spark. That's going to transform our data, store it, put in Redis for online serving, and then the training service. In this case, I'll be using my local Jupyter notebook or local laptop with a Jupyter notebook. Awesome. Like I said, I know I'm going relatively fast. If you have any questions or you want me to zoom in somewhere or focus on something or go deeper, feel free to throw them in the Q&A. Also feel free to just, if you're on Twitter or LinkedIn following in, to just put them there and I'll make sure to answer them. There's just going to be natural breaks where I can answer your questions. Otherwise, I'll keep going. So let's start with an experiment tracker. Why do we care to have an experiment tracker? So these are kind of the basic goals of an experiment tracker. One is a centralized experiment logging. Think of how many notebooks, like imagine if every single time I train a model, I just create a new cell in the notebook. I'll end up with like hundreds of those. As I try different hyperparameters, as I try different configurations, different features, different models, how can I go back and keep like compare them? How did this one do versus this one? How did it converge? I just need one place where I can keep track of all of the kind of runs, the training runs that I've had. And that's one value of an experiment tracker. Two is reproducibility. If I have a model, I want to make sure I understand how that model was created. And I want to understand any hyperparameters that were used to create it. So even things as simple or not simple, but as like fundamental as what was the random seed that I used to split that training set? like one goal of having a really or one maybe like test of how good your MLOps platform is can you reproduce any training set in any model at any time? If so, you're probably pretty good. You probably have a pretty strong MLOps platform, but it's rare. Most people can. Most people are not in a situation where they can actually perfectly reproduce a model. And that can be really painful because if you can't reproduce it, then every time you iterate on something you can't reproduce, you're kind of going further and further away. And it can be really hard to roll back. It can be really hard to keep track of how we even got there. There's a lot of times where I'll find companies where they have a feature that was defined wrong like a year ago or 2 years ago by some data scientist that's not even there anymore. But it's like in 5,000 different files because every single person was just assumed it was correct. And it just becomes a really painful thing to fix. Collaboration and sharing. So you have these experiments, you might want to run them by people, you might want to show someone something, you might want to compare with someone else. You might want to get someone's feedback of like, hey, like my model is not converging. Here's kind of the experiment. Can you take a look at it? Give me some thoughts or feedback. And finally, model versioning and management. In the end, a model is an artifact that comes out of these experiments. Having them versioned is a core piece, and it feeds into the next layer of the MLOps platform, which is deployment. If I don't have version models and I don't know how those models were built, then deployment becomes difficult. It becomes like you see people do things like copying models to S3 and then kind of like downloading them into a Docker file and just having these really hacky solutions to try to kind of get around not having a real experiment tracker. So how does it really look? So this is how MLFlow looks. With MLFlow, you can see that I have a few runs, a few of them failed, a few of them succeeded. You can see this run that I outputted a model, which I'll click on and go into. You can see the source. In this case, it's my IPy kernel. You can jump into here and see the parameters I use to train. So you can see like the training set I use. You can see the model type. You can see the random state, the test size I use to split. If there were more parameters, it'd all live here. Any metrics, like I have an accuracy metric, it's just a number, which is that. But if I had more interesting metrics and conversions, or I can include them here. Any tags, descriptions, the owner, etc. And then the artifact, which in this case is the model. I can see my models. I can see different versions of them. I can put them in different stages from like production or staging, etc. So this idea, this concept of having all of your experiments live in one place, being able to see who built them, when they were built, seeing which models and where the models came from, seeing models that are staged in production, different versions of them, all that is kind of handled by MLFlow. And it requires this very simple changes to your code base, which is another core piece. Like the goal of I view the goal of an MLOps platform is to provide a lot of this value without uh oops provide all of this value without uh really getting in the way. Like I want to still be able to move quickly. I still want to experiment quickly. It's that velocity metric of the MLOps platform. Like I don't want MLFlow or Featureform to get in the way, but I also want to kind of capture all of this context for me. So I don't have to go manually do it, manually version things, manually keep track of my work. So that's an experiment tracker, like MLFlow. On the other side, we have a feature store. So you can think of it like MLFlow is to models as Featureform is to data. So MLFlow is really focused on model management, versioning, experiment tracking. Featureform is much more focused on the feature, like the features, the training sets, the data pipelines, all that stuff. The way Featureform works, our goal is to make it easy for you to define, manage, and deploy your model features. We have a declarative API in the dashboard, which we'll go into. The components are on the left here. You can see that, the goal of this is to build training sets and features that can be served to models, both for training and inference. Featureform is what we call a virtual feature store. So it orchestrates, as you can see at the bottom, that's orchestrating your infrastructure. That can be Spark, it can be Snowflake, it can be Postgres, it could be Redis, it could be Cassandra, whatever. And above that, we provide a framework to give resource repository collaboration, monitoring and alerting, and governance on top of that infrastructure. So you kind of write your logic, whatever you already use. We don't have like a special language. You use Featureform framework to define and manage that stuff, and then we will actually orchestrate it on top of AWS, Spark, Redis, or whatever you decide to use, even on-prem. There's 5 reasons to use a feature store: facilitating deployment, enhancing collaboration, organizing experimentation, increasing reliability, and preserving compliance. For facilitating deployment, this is one that is usually the most painful one, which is I build this perfect feature in my notebook. I use it to train a model, and maybe I used MLFlow to keep track of that experiment, but now I have this great feature. But now I have to get in production, and production is different. In my notebook, I might just be using a sample of data or just use a pandas data frame and kind of do things in a relatively ad hoc way. In production, I might need to pre-process the features. I might need to handle streaming data. I might need to handle a mix of streaming data and batch data and all sorts of stuff. So production is, and I have to handle situations where pipelines fail. I have to build in monitoring. There's just so much stuff that comes in production that I don't have to worry about in my notebook. And the problem this creates is it creates a huge gap, like a chasm between experimentation and production. There's a lot of times where people come up with models in training, and it takes months, if not longer, to get them in production. And sometimes it just can't be done. Sometimes the feature that's done in the notebook can't be mimicked in a production environment. There's a question about Airflow versus Featureform I'll come back to. It's a good question. So getting features into production. So like I said, the way we do experimentation is we work in a notebook, we collaborate, we kind of build these features in our notebooks. But like I said, to get them in production, it's very different. We have to deal with streaming, we have to deal with batch, we have to deal with on-demand features, which are features that can't be pre-processed and kind of get generated on the fly based on the request. That's super common with when the feature is actually generated from request data. So like if someone writes a comment and you want to see if that comment is spam, some of your features are actually going to have to be created off of the comment, which comes at the request time. So this is typically what I see. Either data scientists writing their own Airflow and PySpark jobs, or I see data scientists handing off messy notebooks to data engineering teams or ML engineering teams to get them in production. And our view is that data scientists themselves can and should own the feature from end to end. Because in a way, like as a data scientist, like it lets me like control my fate. Like I can do and I can like I don't have to worry about and depend on other teams to get my models in production and features in production. I can give me a framework that handles all the complexity that's just kind of out of my scope, and I will go and build my features and get them in production. There's a question about Airflow versus Featureform. How's it differ? Are there needs specialist feature or are there needs that are specialist feature engineering? And the answer is yes. Actually, a lot of people use Airflow and Featureform together, but they'll typically use something like Airflow as the highest level orchestrator, and they use Featureform as a framework for the feature engineering needs. What makes feature engineering different and requiring a kind of specialized orchestration? I'm going to skip ahead a little bit. There's a few things that make it different. And when you see the code, it'll also be clear. One thing that makes it different is that in feature form or when you're feature engineering, I need to build features historically for training so that I can kind of go back and be like, hey, what was this feature at this point in time? So I can kind of back test and train a model. At the same time, I need to also materialize that feature in the production in something like Redis so that I can do low latency serving in production. I want to be able to write a feature once and have it exist in both those places. Lots of my feature engineering is going to be really the way I do versioning is going to be very different. Like the framework and the flow, like Airflow is really built for production systems. Airflow doesn't really have this concept of like lightweight experiments. Like, oh, I'm going to try this. Oh, that failed. I'm just going to like tweak this, try this new experiment, try this new feature, train them all on it. Okay, it's good. Let's get it in production. So it's more like Airflow is a generic orchestrator. It can kind of orchestrate anything. Featureform is hyper specific to the feature engineering pipeline. That makes it really, really nice to use for data scientists. Most data scientists I know do not like to use Airflow. They kind of avoid it. And Airflow has a lot of things missing because it's so generic. Since we only focus on feature engineering, there's a lot of context that we have, which allows us to do things like generating data for training sets, generating training sets in production and inference caches. All the pieces that are only specific to a feature engineering pipeline, we do automatically. You don't have to worry about it like you would with Airflow. Even things just like our tie into MLFlow, like that sort of stuff, you don't really get with Airflow. The UI is focused towards feature engineering. There's like feature monitoring, like monitoring how the features change over time, the data drifts. It's a lot of components that make it very different. But as you use it, it becomes kind of clear how they're different. Airflow is built for building like production grade pipelines, and Featureform is built for feature engineering, both in experimentation and training and in production. Great. I'm gonna come back to this one. So let's talk. Nice. You guys are seeing all my memes before I got to them. So the other value of feature is enhancing collaboration and organizing experimentation. And again, like the easiest way to show this is just via memes. Feature documentation, people don't document their feature pipelines. If they do, it's either in a notebook, then you have to figure out where that notebook is and what it's called, and sometimes it's untitled. People copy and paste it, or they send they'll build a CSV and then they'll send it to someone else over Slack. And how did I build that CSV? Kind of gets lost. If I need to recreate it or tweak it in some minor way, it becomes really hard to do. And then this is the one I was just showing, which is it gets more complicated. So having a framework that's declarative, that makes it really easy to share things, makes it really easy to get any data set, any experiment, any feature as a data frame, which is also unique from Featureform to Airflow. In Featureform, everything that gets created can get converted to a data frame very easily, natively in Featureform's framework, where Airflow doesn't really have that concept. Increasing reliability. When features are in production, we won't talk about this that much in this talk, but when features are in production, they change, they move, things happen. We need something like monitoring for drift, for things, for the data changing, for features changing, for features skewing from what they were from the training sets, etc. So most people don't have that today. And it makes it such that you only catch problems when things break. By having all of this extra monitoring in place, you can proactively catch things before it actually leads to bad results. And then finally, preserving compliance. I'm not even really gonna get into this, but Featureform natively integrates into your compliance stack. It natively integrates into Okta, etc., whatever you use, to make sure that all of your compliance is continued to be applied as you're using for data scientists doing feature engineering. Not all feature stores are the same. Everything I've talked about, I've really just focused on the feature form style, which we call the virtual feature store. I just want to take a quick aside to talk about the different kinds of feature stores. When people hear feature store, they think, a database where features are stored. Um, but that's just scratching the surface. One type of feature store, which is the literal feature store, I call it the literal feature store because it literally just stores features. You would transform your data elsewhere, maybe with Spark and Airflow, whatever. And then you would write the feature to the feature store. The feature store will keep historical values of the feature for training. It will also maintain an up-to-date cache of the most recent feature values for low latency serving for production. So it creates one storage layer for both training and inference for features. This is actually, so Feast popularized this. Feast is an open source framework or Feast is an open source feature store that's no longer actively maintained, but it's still, or it was quite popular. Databricks' feature store, Vertex's feature store, all the cloud feature stores kind of mimic this approach. The problem is that most people, when they think of features, they think of the pipeline. To have the pipeline be disassociated or disconnected from the feature itself means every time I iterate on a feature, I have to create a new feature table. But that kind of ruins the point. It makes iteration really painful. And what people end up doing is they don't really use the feature store until the last moment to just like kind of as almost like okay, cool, I've built my features, I've done everything. Now I'm just going to kind of like blast my feature to this store. So it doesn't really help with anything around versioning and management, update tracking, and collaboration. It's more just a unified storage of features. There's another set of feature stores, which we call physical feature stores, where they transform the data for you and they also store it. So this kind of owns the whole stack. This makes it so that the feature is defined as a logic, which we think is the correct way to do things. The problem that we see with these types of products, the physical feature stores, is that they have their own transformation engine. They don't use Spark, they don't use Flink, they don't use Snowflake or the things you use today. They kind of replace it with their own transformation engine. And it's always, I mean, every single one that exists is proprietary. So it's kind of like switching Spark to a new proprietary transformation and storage layer that's optimized for feature engineering. There's value to that, but the adoption cost and the lock-in is super, super high, which is kind of what birthed the idea of a virtual feature store, which is what would happen if we took the idea of a physical feature store, but made the providers, the infrastructure be plug-in. So you can plug in your Spark, you can plug in your Redis, and Featureform will orchestrate them, provide on top of it a unified repository for your transformations, your features, your data sets, your labels, for collaboration, from versioning to lineage to reuse, monitoring, alerting, and governance. The whole kind of gambit of you would expect from a feature store, Featureform provides. And it orchestrates all of this on top of your existing infrastructure. Awesome. Oh, and I should probably give a quick like how it looks before I get into it. So going into like the 5 value props that facilitate deployment, enhance collaboration, organize experimentation, increase reliability. If we look at the dashboard, you can look at things like training set, like I have this fraud simple. I got locked out. Oh man. Here, I'm gonna stop sharing for a moment. Okay, sorry about that. Let me start sharing again. Share screen. Okay, great. So I'm sharing. So yeah, I can look at a training set like this. I can see what the label is. I can see what the features are. Like I can look at this average transaction feature. I was playing around with it earlier. You can see that. You can see the latency when I was playing around with it. You can see any stats and metrics and monitoring on it. You can see the source where it comes from, like the description, the transformation that creates it. You can flow through the lineage. You can preview any of this. All this stuff can be also looked at via code and can also be turned into a data frame via code. Now, let's go into the actual example I have for you guys. Okay. So I'm going to build a fraud training set. I'm going to train a random forest on it. I'm going to use Featureform to version and manage and orchestrate my transformations on Spark. And I'm going to use MLFlow to manage the experiment, track the model, manage the model. So let's run through it. So I'll obviously like just make sure I have everything installed. I'll have Featureform Enterprise installed in MLFlow. Featureform is open source. For this example, like our internal sandbox just runs Enterprise, so I just use that. So that's why I'm running Enterprise. But Enterprise just has governance and access control functionality and stream processing. Everything else is in open source. I'll create my client. I'll point to that internal sandbox. I've already registered Spark and Redis. You can see them in my providers tab. I have S3, I have Redis, now Spark all registered. This makes it such that I don't have to kind of copy and paste credentials and API keys everywhere. I can kind of have the providers, the infrastructure that I use to build my training sets and features and labels kind of pre-configured in Featureform. I can even have user-specific like attributes like API keys if I wanted. I can also look at like I can look at Redis and look at what features exist in Redis, how they're created, what variants exist, etc. But yeah, so I just grab those, and that's really easy. I can just get Spark and get Redis. I can also get any data sets that already exist in Featureform. So I have this thing called transactions clean. So I can look up transactions clean. Oh, clean, or it still found it. You can see how it's defined. I can preview it. I can see the source. The source is the raw data set. The raw data set is in this S3 bucket. I can preview it again. So I can just get this data set. And again, everything in Featureform, every Featureform resource can be converted to a data frame just by calling client.dataframe. So that's what I'll do here. So I'll need to authorize again. So let me just auth real quick. By the way, with auth, you can save like a credentials file. I just didn't for some reason, and that's why it keeps making me re-auth. So yeah, I can get anything as a data frame. I can define transformations. Like off that raw data frame, I can create a transformation which takes the customer. See, I have a few columns here, like customer ID. I have customer account balance and transaction amount. So this is a data, and if it's fraud, I can, in this situation, I want to build a column which is, the amount divided by the balance. The issue is that sometimes the balance is zero and sometimes the balance is zero. When the balance is zero, I'm dividing by zero, which is bad. So I default to 100 if the value is zero or if the balance is zero. Notice that all this code, this right here is just PySpark. Like with or without Featureform, you would write the exact same code. The difference is that you put it in this, again, this framework where you're giving a name. This is the name that we'll deduce. You can choose to give it a variant if you want to. And you can give a description, and we'll just take the PyDoc. And again, this becomes searchable and anyone can use it. So I can go here, I can find percent balance, I can find that variant, I can see how it was defined, and I can get this as a data frame. I can preview it, I can see what features are kind of derived from it, etc. The other cool thing, which I find cool, is if you remove the variant, Like when I'm playing around with things, right? I don't want to like set a variant. Everything's immutable, which I think is an important note. So everything is immutable. So if I have a name in a variant, it's can't change. There are pieces of it that can change, like the schedule and other things, but the logic can't change. And when I run it like this, it will automatically create a variant. So you see, it'll create a variant, and actually, this derives it based on uh, the timestamp, the datetime. And it will, right now, like Featureform is running it for me on Spark. And so I can, because I'm calling client.dataFrame, it's going to run it for me when it's ready or retrieve as a data frame. So it'll feel very, very natural to my workflow. After this runs, this takes like, I think the data set's relatively big. So it takes like a minute maybe. Um, but let's say for some reason I ran this and there's an error. Actually, I probably should have made it an error first. Um, After this runs, I can change anything here. And when I change something, it will actually create a new variant. So that's the nice thing. Like I can just change things. I can change the code. I can just keep rerunning the cell like I would without Featureform. And Featureform will create all the different variants for me. So now I'm like, huh, actually, I want to make this 0 instead. And I run this again. Like it will create a new variant. Now the old one's still there. Like if I go back to my percent balance and let me just refresh, and I look at my variants, you can see that there's two. There's one which was the original one where I had to add 100, and there's one which is pending because I'm building it where it's 0. If I was to switch it back to 100, it would reuse this one. So it's smart enough to reuse things that already exist and avoid you kind of having to redefine the same thing over and over again. I build a different transformation. This one's more complicated. This has point in time correctness. So I have a timestamp. I'm kind of creating a window of 30 things that I'm averaging across the last 30 items. The nice thing here is that even though that value, that feature is kind of changing per user every time they make a transaction, when I build a label in a training set, it will automatically grab the feature at the correct point in time based on the label. So if there was a fraudulent transaction 3 months ago, it would grab the feature as the feature would have appeared 3 months ago, not what the value is now, which is what you need to have correct training. If you don't train that way, your model will really suffer in production. So I define some set of features. Featureform also copies it to Redis. Optionally, I don't have to set an inference store. But if I do set an inference store, Featureform will maintain an up-to-date cache of the most recent values in Redis. This means if I serve for production at serving time, it will use Redis, which will be obviously much faster for low latency serving. So I build a training set. Featureform will build all these things. It will copy into Redis. It will do all that for me. I'm just declaratively defining all my features and my labels and my training sets. And then I can train my model. This is where we're going to swap from Featureform to MLFlow. So in Featureform, I call client.trainingset. I call the name and the variant I want, which is fraud simple. I can optionally specify a model name, which is a string, which pretty much allows Featureform to tie the model to the training set, to the features, all the way down to the raw data. So I get the whole lineage from model to features. If I reuse the same model name in MLFlow, I can actually track experiments and track everything from end to end, which is I think is just really valuable and really cool. So yeah, if I run this, it'll take a bit, but I can show you an old one in the meantime. But let's run this and then I'll explain the code. So I'm grabbing that data frame. I can get any training set as a data frame, a pandas data frame, which I'm doing here. I can get it as a Spark data frame, or I can get it as a stream of mini batches, depending on what I want. I'm running MLFlow just locally. I kind of do a quick test split. Then I start using MLFlow. All I have to do with MLFlow to work is call, with MLFlow. I create a classifier. This is just like scikit-learn. This isn't MLFlow. I train my model. I get the accuracy. And then I log all the parameters, anything that's relevant or valuable to that model. So the parameters are anything I need to be able to reproduce this model. Metrics are kind of outputs or kind of things that are relevant metrics in training, like accuracy. And then I can also log the model itself, the output model. I can then even register that model like officially in the MLFlow registry, which I also do here. So what MLFlow does is it lets me tie everything in a run and then add all the parameters I need. So when I look at MLFlow, I can look at or ever look at an experiment. I have one running right now. You can see it. Like there's nothing here yet because it's still running. But for the experiment that I ran earlier, you can see the parameters, you can see the metrics, the accuracy, all that stuff. So there's a question which is, will feature calculations be performed in the cloud or in the Featureform server? Is it possible to execute all the computations on a dedicated server and only register the code variants in Featureform? Yeah, so Featureform doesn't actually like have a compute engine. Featureform runs on Kubernetes. We can run jobs in Kubernetes. If you try to run like a pandas job, we'll run it via Kubernetes. But typically, like what I did here is I registered Spark, right? And then I just grab my Spark my Spark resource from Featureform. And I call it Spark. Now notice when I define this transformation, I use this Spark variable and specify this is a Spark data frame transformation. Here are the inputs. Here's the transformation. Here's the description. Here's the name. When Featureform ran this, Featureform actually ran this on Spark. It did not run it on our own stuff. Featureform is just an orchestrator in that way. And this is what is the difference between a virtual feature store like Featureform and a physical feature store like Tecton. The physical feature stores, they have their own transformation engine. With Featureform, we are using your transformation engine, whatever it is. Even if it's like some features are on Snowflake and some are on Spark and some are in Pandas, we can do all of those. Great question. Thank you. Okay. So coming back to MLFlow, you can see I built these parameters. I have these metrics. I have this artifact. I can see the models that are created. I created a new model just now. You can look at that model as well. The other cool thing is in Featureform, I can look at the models that was created, like the one I just created, or rather, let me look at the most recent one. Usually I wouldn't put these names of like just timestamp strings, but it's useful in this situation. I can look at the training set that this model was trained on, which is fraud simple. And I can actually go through this. I can go through the features. I can like go and really dig down and really understand what this thing is, how it was defined, etc. Like I get the full lineage from model all the way down to the feature. And then on the MLFlow side, if I look at an experiment, like the most recent one of the parameters I logged is actually the URL for Featureform. So I can be like, like what was this trained on? And I can just get that here. Finally, I kind of on purpose, like I didn't really want to get into like how do I productionize these features, etc. But I thought I'd give a really quick example. So I'm going to create an on-demand feature because I want to be able to define a feature off of parameters that come at request time. So when a transaction comes in, I want to take the parameter, transaction amount, and divide it by the feature in Featureform balance. So I'll define this. Now, when I want features from Featureform, and I want pre-processed ones to come from Redis, which will happen automatically because I registered them with Redis. and the on-demand one to be processed at request time quickly. So I specify all these things to get the features. I can then load my model from MLFlow just by name, and I can make a prediction. So if I run this, you can see it's downloading the model from MLFlow. It got the features almost immediately from Featureform, and then it used those features from Featureform and applied the MLFlow model on it. And it predicted that this was a fraudulent transaction. So what did we do here? Without Featureform and MLFlow, we would just have written these PySpark jobs directly. We wouldn't have had this kind of function syntax. Without MLFlow, we would have written the same code, but we wouldn't have had these logs, and we wouldn't have had this with statement. So in the end, I've probably added like 15 lines of code, if that. In return, everything I've done was now tracked, versioned, reusable. I can collaborate on it. I can share it with people. They're all monitored. I get all of that, not for free, but more or less for free. Like the amount you have to do and the value you get, especially if you're a larger organization, especially if you're in a situation where, bad things happen, if you screw up compliance, if models go bad in production. Just having an experiment tracker and Featureform together from a data scientist perspective is a very low lift and provides a ton of value. From an engineering perspective, data engineering, ML engineering, it makes things a million times easier if your features and models are managed and tracked in MLFlow and Featureform. It makes it really, really easy, like I showed you here, to serve them in production. So that's all I have. We have 5 minutes. I can go a little over, but just I'll answer any questions that come in. We have one here. Will it be possible to use a previously defined Databricks job instead of defining the transformation code? That's one. And will it be possible to read from Databricks tables directly instead of underlying data? So great questions. The short answer on the Databricks jobs and the Databricks tables. With the Databricks tables, that can be done because the Databricks tables underneath the hood are just Delta tables, which we support. And then on the Databricks jobs piece, can we redefine transfer, or can we just use a Databricks job as opposed to redefining code? Not today. It's something that we've been asked about, like even like running jars. We don't support it today, but it is something that's on the roadmap, not in the next month or two, but it's definitely on the roadmap. If you want to kind of in the open source community join and give us your use case and your thoughts, that helps us prioritize. If there is a really interesting use case and a specific user at the end of it, it might help us prioritize some of that stuff. How people typically do what you're describing, like, is they'll use some other maybe Databricks to build their data sets, like the data mart. And then the data scientist doing ML will work off of the data mart. So in that situation, people will use like something like Airflow or Dagster to build the data mart. And then data scientists doing machine learning will use Featureform for kind of the last mile transformations, all the transformations that happen after the data mart. And so you can kind of register the Databricks tables as primary data sets as opposed to derived data sets. And it can work together that way. Great question. Would love to understand your use case better. If you join our Slack or reach out after, it's kind of not questions I've heard that often, so I'm curious to understand your use case. Okay, another question. If an online model and has some input parameters from the backend, does it also get captured in Featureform? If I want to see model features, it should be a combination of input backend feature allowing the feature to be created. Yeah, we log every single feature served. And so we use that for monitoring. So you can even see if the distributions of features you've served in production differ from the features in training. But yeah, we keep track of all of the features that were served. And you can use we use them for metrics and monitoring. Great question. Awesome. That was a lot of cool questions. We have 2 more minutes. If there are any more questions, Maria, I don't know if you've looked at LinkedIn and Twitter, if there are any questions there that I could answer.
I think that's all the questions. I think you answered them all.
Cool.
Awesome. Thank you guys so much for attending this workshop. Following up on what Simba said, I am gonna send you all just like a little follow-up email. It'll have this recording. It'll also have links to join our Slack if you want to keep the conversation going, as well as some other docs and tutorials and stuff. Awesome.
Cool. And I'll just give it another minute. Maybe someone else has any
Recording.
last questions.
It'll also
But if not, I'm gonna make you host again while we're doing this so you can end it. Um, you host, change host.
cool.
Cool. All right. Thanks, everyone.
Yeah, thank you guys. Have a great rest of your day.